Hey everybody, this is Larry. This is day 25th of June of Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm. So I'm not gonna lie, I drank a little bit of alcohol earlier, and by a little bit I mean probably a little bit too much. So yeah, we'll see how my reaction time is and all this stuff. But hope y'all are doing alright at home. This is kind of intense. Yeah, it's just been a really weird day, at least in the U.S., with the Supreme Court kind of, you know, overturning some really important precedents. So, yeah. Anyway, okay. So today's problem is 665 non-decreasing array. Given an array nums of n integer, your task is to check whether non-decreasing by modifying one element. Okay. 4 to out. So nine. So yes, like increasing, but not. It's monotonically increasing. Okay. Yeah. So I mean, I think this is a dynamic programming problem, I believe, because it is just basically doing greedy, but with you could do it with memoization, with dynamic programming. Otherwise, you can do it. N squared is going to be too slow, and n is of course 10 to the fourth. So okay, so yeah, so the recurrence here, and I don't know, I probably am not being articulate, is that there's only one state, right? Is that you get it implemented with two functions. One is starting at this index, I've used one element, and then starting at this index, I have not used an element, right? So let's try, right? So then we have say check without, let's just say without using. That's a little bit awkward, but you get the idea. We have an index, and we talked about dynamic programming before. The index allows us to kind of map to the numbers array, so I'm just going to go by that. Oops. Yeah, if index is equal to n, that means we got to the end and we return true. Otherwise, if num sub index is less than or equal to num sub index plus 1, index plus 1 is equal to n, say, then we return check without using, right? Plus 1. Otherwise, that means that this is bigger, then we should return. Actually, I messed up a little bit. So then we have to consider whether we can return this, right? So if we can return this, then we return true, right? Otherwise, if we cannot do it without using, and I guess I'm just combining this. If you can do this with, or if you cannot do this without using an extra element, then we check it with using, right? I think this is a little bit awkward though, so let me think about how to write this. No, I think this is. This is the general idea, but I'm thinking about how to fix this, right? Because this isn't quite right. So what I would do is just write one for check with as well, which is index. But this is going to be wrong, just to be clear. I know that this is going to be wrong, but I'm just writing it out. And then the idea is return if something like that, right? But then this is going to be wrong because I think the idea here is that or maybe we could rephrase it in a different way. Because my idea is that, okay, let's say you have something like 423, right? And then the idea is that there's actually two ways to fix this. One is by, let's add a 1 here just for these more general. generality. But let's say one way is turning this 4 into 1, right? So you can go into the 1, 2, 2, 3. And then the other way is maybe changing the 2 to a 4, right? Of course, this won't work per se, but in theory, you could imagine us going here and then look at the rest of the thing. And right now, we don't really capture both those cases in a good way. So we have to think about, or I'm thinking about, how to kind of cleanly do this, right? So what am I writing here? So what I'm writing here is that I assume that by skipping this number, so that means that this is less than this number. What are we writing exactly, right? So we have this case. What we are writing is that we assume that we make this number small enough so that we get the next number. But we also want to consider a number where we make this next number small enough to continue the streak, right? So I think that's basically the idea. Is that, so right now what we do is we skip. So then by skipping, what we're saying is we're making it here. So we're making this 1, or let's just say even 2, right? Doesn't really matter because we're skipping to the next one. But we don't consider this case where we skip to the 4, right? And maybe we could skip to the 3 because now, no, that's not quite right either, right? Because if we try to skip to here, maybe I should have to add more stuff as well. So maybe this isn't actually just right in general. And we have a bad case in that I was just generalizing. But let's say we have 3, right? We have 3 here as a beginning. Then we cannot change this into a 2 because, well, then that is not increasing as well. So actually I'm wrong here. I blame on alcohol, but at least I didn't submit yet. But I think we just need to do additional check, which is that if index -1 is less than 0, or index -1, and I'm a little bit slow right now because I'm still I know by moving that I'm not 100% yet. The liquor is still in the system, but basically, if this is this, then what, right? Why is this weird? If this is the case, then we have like something like this, then we can make the middle number go away. So then we can skip to the next number, right? So here, then we can go, and then we just add with check with index +1, return true, right? And then we have to do the other case of 2 numbers ahead of, okay, let's actually convert this number, right? Then what do we do, right? So then if index +2 is, you go to n, so that means that it goes out of bounds. Or num sub, what am I saying here? So this is the index. We want to replace index +1 by this number. So if index is less than or equal to num sub index +2, then we check with index +2, because now we're modifying one number, which is the next number, and then we return true. I may have some weird off by ones, but I think this is generally right. So yeah. So then now we can return check without using of 0. Oops. Again, my motor functionality, it's a little bit off today. So let's see how that goes. That's not good. 421. Why does it think 421 is good? So it goes to 4. I'm too slow right now to really figure it out, but let's say we're at 0, right? So we know that this is not true. this is, oh, well, no, this is true. We just go to index plus 1, 2, 1 should be return false, unless I'm missing something here. So yeah, so that's good. And then index plus 2, so we're at 0, we go to 2, and then this is not true as well, so it should return false. Why is it returning true? Right. Just wonder real quick. Definitely not at 100%. Sorry, friends. Okay, so it doesn't print here. So how is it returning false? Oh no, it's returning true. Sorry, I confused myself. Okay, so it returned true in one of these. Without. Okay, skip the next one maybe. This is what I'm trying to say. So 0, 1 with, so that's this one. So basically we're saying, okay, so this part is, no, this is true, but then it goes to check with index plus 1, index is 0, so then it should be just 2, 1, right? So then why is check with, did I mix this up? Index plus 1 is 1. Why is this right? Oh, I am dumb. This isn't return true. This is, well, I mean, it's still wrong another way. But what I meant is that this should be checked with index plus 1. Because if it's bigger, then we just check the next number. And the reason why we do it this way without instead of a for loop is something that we'll see later as a result. Is what I call DP loop rolling or unrolling. So yeah. Anyway, so why is this true? Oh, I didn't do the parents. I am just being sloppy. I think this is roughly right, but I didn't do the parents, so the precedence, the order of operations. I'm just very sloppy. Sorry, friends. So that looks good now. I just forgot to. I mean, I didn't forget, but I just didn't pay attention enough, and I made a mistake about it. Sorry, friends. But yeah, so this looks okay. And of course, the problem is that, we're doing 3 branches here and 1 branch here. So this one's more easier. So the thing that we would do is by adding a thing called memoization. And what is memoization, right? Memoization, the core part of memoization is basically for every input, we return the same output. So we could do that very quickly. So hash without cache. And I'm not gonna lie, today I'm a little bit off, so yeah. So I'm not gonna go over this part too much, but the idea is just checking whether these things are matched up. So if hash without cache of index, return without cache of index. This part is actually annoying to do. Sorry, friends. This, though technically speaking, this is slightly worse because it doesn't have early termination. But yeah. But that's basically the idea. I'm just a little bit lazy on the writing. We can write in a way that does have early termination. But as I said, I am a little bit. I'm actually a lot tired today, friends. Sorry. But I know I apologize a lot, but it's just been a tiring day. But yeah, but in general, this is how I would write it. I guess I could have also showed. I guess I could have showed this timing out before, but it's fine, I suppose. Make sure that it was. Let's give it a quick submit. I'm really tired, so let's give it a quick submit and see how it goes. Oh no. Did I not fix that? I thought I checked for this. I should have put this in a test case and ran it before, to be honest. But so basically, it. Oh, basically this should be greater than. That's my fault. I thought about this, but then I thought I couldn't reach out. But then I changed the way that I did it, and I was wrong. Silly mistake. Oh, yikes. This seems way basic. Why was this not caught? Sorry, friends. I guess the last couple of days I've been a little bit sloppy, but let's see. So this is the previous one. And then it looks at the current number. Oh, I guess this actually true. Is the n plus 1 is I am very sloppy. Whoops. Alright, let's give it a quick submit, even though I probably could have tested a little bit more. But I am really tired, as I said. I mean, these are just two very sloppy mistakes. I think this is, algorithmically speaking, it's good. Implementation wise, very, very sloppy. Do not recommend you do what I did. As I said, today I'm a little bit off because I feel like I should be able to do this in like 5 minutes, to be honest. My I don't know how long I talk because I do usually talk a bit, but 17 minutes right now in the video is a little bit long. Okay, that's it. I have 816-day streak, and then the complex is just dynamic programming. And for this function, you could see that there's a linear number of possible inputs because index, right? So this is O of n time and O of n space because we do at most 3 cores. I usually write it out. I'm really tired. I'm just gonna pass out. But and here, this is also linear time, linear space for the same reason, right? There's linear time number of inputs, each input taking O of 1 time, and that's pretty much it. Yeah, I'm a little bit tired, friends, so hopefully tomorrow I'll come back stronger. But for today, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.